Hello class, let's start chapter 3 of our geography, motions of the earth. In this chapter you'll study about movements of the earth, inclination of the earth's axis, rotation of the earth, revolution of the earth, varying length of day and night and seasons, movements of the earth. The earth rotates on its imaginary axis from west to east in about 24 hours. This motion of earth is called rotation. The earth also moves around the sun in its fixed path known as orbit in 365 1 by 4 days or in a year. This motion of the earth is called revolution. This is an image of earth on its axis. Inclination of earth's axis. The axis of the earth is not perpendicular but tilted to one side. It makes an angle of 23.5 degree from the vertical or perpendicular line. That means the earth's axis makes an angle of 66.5 degree with its orbital plane. This tiltation of the earth's axis is called the inclination of the earth's axis. The rotation of the earth causes day and night, and the revolution causes seasons. Rotation of the earth. The earth faces the sun while rotating from west to east. Each part of it is illuminated by the sunlight turn by turn. The lighted part of the earth facing the sun has day, while the other part of the earth that is not facing the sun is dark and has night. Thus, as the earth rotates, the day follows the night and the night follows the day turn by turn. This image is showing the rotation or revolution of the earth. Rotation of earth on its axis and in orbit around the sun. Let's perform the phenomenon of day and night by an experiment. We need a globe and a table lamp. The globe represents the earth and the lamp represents the sun. Keep the globe on the table and place a lamp in front of the globe in a dark room. Mark a point G on the globe to represent a place. Switch on the lamps and observe the lit half and the dark half part of the globe. First, place point G of the globe in the dark side. Rotate the globe from west to east. See that G place is moving towards the light in the direction of the lamp, representing the sun. Notice G first in a diffused light. It is the position before sunrise and the time is called dawn. The rotation of the earth gives rise to the concept of time. The time when the sun appears to rise is the morning time. When it is overhead is the noon time, and the time when the sun appears to set is the evening time. The regular occurrence of high tides and low tides twice a day is also due to the rotation of the earth. The progressive westward movement of the tide can be explained by the rotation of the earth. We notice that a moving body or wind or ocean current is deflected towards the right in the northern hemisphere and towards the left in the southern hemisphere. This is also due to the rotation of the earth on its axis. The revolution of the earth. The movement of the earth around the sun is called revolution. The path on which the earth revolves around the sun is called orbit. The orbit is elliptical in shape. Thus, the distance of the earth from the sun does not remain the same during its revolution. The distance between the earth and the sun is 147 million km on 3rd January. This is the minimum distance. The maximum distance between the earth and the sun is 152 million km on 4th July. The earth completes one revolution in 365 days and about 6 hours. For our convenience, we consider 365 days in a year. The remaining 6 hours are added over a period of 4 years till they become 24 hours or 1 day. This extra day is added to the month of February every 4 years to make it a month of 29 days instead of 28 days. The year of 366 days is called leap year. The revolution of the earth around the sun not only causes the variation in the length of day and night but affects the distribution of heat over the earth's surface. The occurrence of different seasons is the most significant effect of the revolution of the earth. Varying length of day and night and seasons. Varying lengths of a day and night and seasons are due to rotation, revolution and inclination of the earth from its axis. Let us find out phenomena of length of day and night and the occurrence of different seasons on the earth by the help of a diagram. The positions indicate the four seasons and their changes one after the other to form a cycle of season. This diagram is explaining Earth's revolution and its position on particular dates. Earth's position on 21st June. When the revolving Earth reaches this position, the northern hemisphere is inclined towards the sun and the southern hemisphere is away from the sun. The rays of the sun are vertically at the Tropic of Cancer, 23.5° north. The larger portion of the northern hemisphere faces the sun. As the lit part of this hemisphere is more than the half, length of the day is more than night. The duration of day increases towards the pole. The Arctic Circle faces the sun for 24 hours. The sun rays are more slanting, therefore it is winter season in the southern hemisphere. This position is called summer solstice in northern hemisphere. Earth's position on 23rd September. The revolving Earth comes to this position after 3 months. The sun shines vertical over the equator. The days and the nights are equal in both the hemispheres. This situation is called equinox. In this position, both the hemispheres receive equal amount of heat and light. It is autumn season in the northern hemisphere, so the equinox is called autumn equinox in the northern hemisphere. Earth's position on 22nd December. The Earth continues to revolve and the southern hemisphere gradually comes towards the sun. In this position, the sun rays are vertical at the Tropic of Capricorn, 23.5° south. The length of the days increases toward the south pole. The nights become shorter. It is summer in southern hemisphere. It is called summer solstice for this hemisphere. Just opposite to it, the northern hemisphere is away from the sun. Days are shorter than nights. The sun rays are more slanting and it is winter in this hemisphere. This is called winter solstice. Earth position on 21st March. The Earth comes to this position after 3 months. The sun rays are vertical again over the equator. Both the hemispheres have 12 hours day and 12 hours night. Both the hemispheres receive equal amount of heat and light. It is spring in the northern hemisphere and is called vernal equinox. Thus, the cycle of season continues year after year. Do you know? Equinox means equal day and night. The North Pole has darkness for about 6 months from 23rd September to 21st March, whereas the South Pole has sunlight during this period. The North Pole has sunlight for about 6 months from 21st March to 23rd September, while the South Pole has unending night during this period. Summing up, the Earth rotates on its imaginary axis from west to east in about 24 hours. This motion of the Earth is called rotation. The Earth also moves round the Sun in its fixed path known as orbit in 365 days or in a year. This motion of the Earth is called revolution. The rotation of the Earth causes day and night and the revolution causes seasons. The lighted part of the Earth facing the Sun has day, while the other part of the Earth that is not facing the Sun is dark and has night. The rotation of the Earth gave rise to the concept of time. The movement of the Earth round the Sun is called revolution. The path on which Earth revolves round the Sun is called orbit. The Earth completes one revolution in 365 days and about 6 hours. The year of 366 days is called leap year. Varying lengths of day and night and the seasons are due to rotation, revolution, and inclination of the Earth from its axis. The days and nights are equal in both hemispheres. This situation is called equinox. Thank you, class. Let's meet in the next class.